Hello, everyone. So this is going to be a little bit of a review worksheet for our eventual Chapter 8 quiz. We basically have two different types of situations going on with sampling distributions. We have sampling distributions of sample means, and we have sampling distributions of sample proportions. So you can print this worksheet out or you can just work along with it. But what my goal of this video is, I'm going to make two videos. One for question number 3, that's this video, which is an example of sampling distributions of sample means. And then number 4, I will do a separate video for sampling distributions of sample proportions. So you'll have two videos. And what these videos are going to do is they are going to walk you through each step. And there are going to be times where the video stops and you're going to have to answer a question to move forward. So that's how I'm going to actually check the assignment. So you're not going to need to take a picture of your work and submit that or anything like that. Watching the video and answering the questions will be how I check the assignment. So starting off with number 3, let's take a look at what we have going on. A manufacturer of cereal states that the average weight of cereal in a box is 10.5 ounces, and there's that mu symbol. So that's what leads me to believe or know that we're talking about sample means here. And when we're talking about sample means, our symbol is X bar. That's the mean of the sample. And the standard deviation is 0.2 ounces. Okay, so this manufacturer claims that the average weight is 10.5 ounces with the standard deviation of 0.2 ounces. So there's variation there, of course. What we're going to do is we're going to check to see if we would question that claim of 10.5 ounces by sampling 100 boxes of cereal and finding the mean weight of those samples. And so we're going to look at two examples. Would we question their claim of 10.5 ounces for an average if we get a sample mean of 10.48? Would we get a question, or would we question the claim, or would we be like, if we got a sample mean of 10.45 ounces? Meaning, what's the probability of getting each of those? What's the probability of getting a sample with 10.48 ounces if the true mean is 10.5? If there's a very, very low percentage of that, then we would question the manufacturer's original claim. That very, very low percentage we look for is 0.05. If the probability of getting a sample mean is less than 0.05 given a population mean, then we would say that's a low enough probability that we would question their claim. All right, we're going to come back to that. Going back up, we need to talk about what the mean and the standard deviation of the sampling distribution of the sample means are. So your sampling distribution is if you found every possible sample mean for n equals 100 boxes, every combination possible, what would the mean of those samples look like? What would the standard deviation look like? And for sample means, our formula is the mean of this distribution of sample means is equal to the population mean. So in this case, the mean of our sample means is equal to 10.5 ounces. The standard deviation of your sampling distribution of sample means is the population standard deviation divided by the square root of n. So in this case, it's going to be 0.2 divided by the square root of 100, which gives us 0.02. Now, before we can do anything, we have to say, can we assume our sampling distribution will form a normal distribution here? Why or why not? The answer here is yes. because our n is 100 and it is significantly large. For sample means, you don't have to find a formula. There's no multiplying that you have to do and be greater than a number. It's just if n is large enough, and usually that's when our n is greater than 30. Okay, so now getting to questioning that claim of 10.5 ounces. Would we question the claim if we got a sample mean of 10.48 ounces? So because we know we have a normal distribution, we're looking at if that true mean is 10.5, what's the probability that we get 10.48? So we're looking for that probability. If it's a really, really, really low probability, then we would question their original claim. What you're finding here is then the probability that our sample mean is less than or equal to 10.48. Go ahead and calculate that using your calculator. Okay, so using your calculator, I have my calculator example down here. Our lower bound here, it's a less than or equal to example. So our lower bound here is either negative infinity, -1 times 10 to the 99th power, or you could just type a really low number in, -1, 0, 0, 0, 0, lots of zeros. I'm going to make my font a little smaller here. Oops. And then our upper bound is 10.48. So what's the probability of getting 10.48 ounces or less if the mean is 10.5 with the standard deviation of, and we need to use this standard deviation, the 0.02. Enter, enter, enter all the way through, and you will get your probability. Now, which we got this to be 0.159, based on this, answer the question, would you question the claim of the average weight being 10.5 ounces? And the answer is no, we would not question the claim of the population mean being 10.5 ounces because there is a 15.9% chance of getting a random sample mean of 10.48 ounces. And that's not a low enough percentage. What was that percentage that I said we wanted to be lower than? Right, 5%. So this number has to be less than 0.05. The next question takes it down a notch. What if we got a sample mean of 10.45? So that's really even further less. So what is the probability of this happening? Would we question the claim? Why don't you go ahead and use your calculator to do that? All right, everything's the same on your calculator except our upper bound is now 10.45. And so the probability that our sample mean is less than or equal to 10.45 is 0.006, which is very, very low. Is that less than our 5% threshold we were talking about? Yes, it is. So yes, we would question the claim of 10.5 ounces because the probability of getting a random sample mean of 10.45 ounces is 0.6%, so less than 1%, which is extremely low. Hopefully that was a good review of sampling distributions of sample means. Question number 4, I will work through with you in another video.